Hello guys, welcome to the video. In this video, we are going to discuss our question, traffic rainwater. So let's first understand our question. In the input, we are given a non-negative integers array that represents elevation, where the width of each bar is 1. Elevation or height. We are required to compute that how much water it can trap after raining. Let's understand it. Okay, our question. So this is our array given to us. Okay, so these are the height represent array elements. Let me write it for you so that you don't get confused. So let's say the first 0th index we got 0, that's why there is no height, right? Then 1, then 0, then 2, then 1, 0, 1, 3, 2, 1, 2, 1. So this is the array that is given to us. So what happens? These elements represents height of the array, right? So what happens is rain. So rain happens, right? Just like this. Rain happens and the water get trapped, right? And where water get trapped? Let's see. Let's see. So here water get trapped. Here, here. Also before that, I want you to focus on this. That we are given that every width of each bar is 1 unit, right? So it's 1. The water get trapped. Now you must be wondering that I have trapped water here, but how? Like, how do you determine that where I am trapping my water? We will discuss about it. First, let's see the output for our input, our given input. So this is total 1 unit of water trapped. Here it is also 1. This is 1, then again 1, right? Here also 1. So 1, 2, 3, 4, 5, 6. So for this, our output will be 6. Perfect. Output is 6. 6 unit of water trapped. Now, you must be wondering that how did I determine when water got trapped? So, let's see. Let's see for 2th index first. So in 2th index, how much is my height? My height is 0. That's perfectly right. Now, what is then? Let's see the right. Like, what is in my right? It's 2, right? 2 element, that means 2 height. And in the left, I got 1 height. You can say there's building of 1 height in the left and 2 height in the right. So how much water is stored here? Here, 1, right? Here, 1 unit of water is stored, right? Then I'm showing the example. Then I want you to analyze it yourself. What is happening, right? So here, let's see one more for the 9th index. So 9th index, my height is 1. My height is 1. My neighbor height is 2, right? And my right neighbor height is again 2. So here, how much water got trapped? Let's see. So try to analyze it. What is happening here? How much water get trapped? So here, in the first, in the left we got 1, and the right we had 2, right? They both had bigger height than us. So first point that we know, if the left building and the right building, they got bigger height than us, then water will definitely get trapped. Now, how much water? Minimum of them, right? Minimum of them. So here, left height was 1, right height was 2, so water got trapped was 1, right? Here, 1 water got trapped. Here also, their height is same, right? They're 2, 2. So that means you can store 2 unit of water here. But no, your height is also 1, right? So of course, overall you can store 2 units, but your height is 1. So that means by this I can derive a formula. What is my formula is? Let me write it here. Let me write it here. Then we'll verify. Is it true or not? So what I'm saying is that the minimum of left max and right max, whatever is the minimum of them, minus my own height, that amount of water will get trapped, right? Trapped in my index, right? Trapped water will get trapped. So now let's verify, is this true? Whatever I'm saying, is it true? So let's see for this array. Here I have pasted this formula. So starting for 0, so we know the right max is 1, but there's no left max. So here water can't get trapped. At 1 index, let's see. The right max is again 2, but there is no left max, so no water can get trapped. Of course, you need someone to hold your water. You need at least, you need two buildings, right? Or two high elevations so that your water can get trapped. Now at 2th index, your right is 2, your left is 1, minus your height, here that is 0. So of course, you can store 1 unit of water because 1 is minimum. At 2, there is no left max, so you can't store. At 1, right max is 3, left max is 2. Whichever is smaller minus my own height. So I can store 1 unit here, right? Here at 5th index. Right max is 3, left max is 2. 2 is minimum minus my own height, that is 0. So I can store 2 units of water here. So that's 1, right? Total 2 units of water. Now at 6th index, my right is 3, my right max is 3, and my left max is 2. So here, how much water I can store is 2 minus my own height, that is 1. I hope you are getting me how I am getting into it. For 3, I got no left max as well as no right max, so I can't. So water will not get trapped here. At 8th index, left max is 3, but there is no right max, so no water will get trapped. At 9th index, yes, we got both left max and right max, and they both are 2 minus my own height, so I can store 1 unit here. So we as you can see, they are both the same figures. So that's the formula to calculate how much water will get trapped. Now we know the formula. So the first approach that you must be getting is to traverse. That's brute force, right? Traverse. Then for every element, calculate its left max, right? So again, for example, you are traversing using I. Then for left max, you're gonna go from I to what? To 0, right? And for R max, you're gonna traverse from I to the last element, right? To calculate your left max and right max, right? And then of course you know your height minus your height. But as we can see, this operation is costly, right? Not a optimal approach. So now we will be discussing some optimal approach, right? So now this time, what we can do, that instead of traversing, like here we traversed, what we can do is keep calculating the left max and right max using our stack. Of course, we can do this. That would be a good solution, right? Using your stack. But I hope that you have understood what I'm talking about. So what we will be doing is to calculate our left max and right max using stack. So that will be a ON operation. Now this time we won't be discussing that approach. Instead, this time we will be discussing the approach that is similar to our question that you might have already done, largest area histogram 2. If you have not solved that question, if you have not watched that video, I recommend you to watch that video and then come here so that you understand it completely what I am talking about. Okay. So here is our array. So let's think what we did in our largest area histogram. In that question, we calculated our next smaller left, just right in one traversal, in just one traversal. Okay. So what I want to show you this time, let's take for 2th, right? For 2, we are just gonna get the right just maximum and the left just maximum. In this case, it is the right just maximum, or I can write next greater right, next greater left, right? So in this case, for 2th index, the next greater right is 3, the next greater left is 2. So I'm gonna check who is minimum. So let's keep writing our formula. Okay, so I'm gonna check who is minimum. So minimum of next greater right and next greater left. right? Minus my own height. In earlier, what we did is minimum of left max, right max minus my own height. But this time there is a catch to this. Let's see. So for 2, 3, we know that 2 is minimum, right? So 2 minus my own height, that gives me 2, right? That gives me 2. So here I can store 2 unit of water, right? As you can see. But what's the catch? If you use your old formula here, that was minimum of minimum left, minimum right, minus 1. So what would that be, right? If we talk about our old formula, so it would be it was maximum of left and maximum of right. So it was 5 and 4, max right and max left is 4, right? So you would have get 4 and 4 minus 0, right? 4 minus 0, that is 4. So that means you can store 4 unit of water here, right? But here we are just getting 2 units of water. So why is that? How will you compute our answer? So we will be using help of width. How is that? So let's see this case first. So for 2, or let me erase this so that you don't get confused. I hope you are understanding the difference between what I'm trying to say. All right, stay with me. So for 2, the is next greater left is 4 and next greater right is 3, right? So how will you compute the height? It will be 3 minus 2, that is 1, right? So that means you are going to store 1 unit of water here, but this time you're going to check the width between next data right and next data left, and you're going to multiply it. So that means you're going to store water here as well, right? I'm going to show you one more example, then you are going to completely understand what I'm talking about. So let's see for 3. So for 3, the next data right is 5, the next greater right is 5, right? And next data left is 4, right? So again, if I calculate, it is 4 minimum of both minus 3. That is 1. So 1 here, right? And this time I'm gonna place calculate of whole width, right? Of course, for my whole width, so it will be here as well. Here as well as here. So just like this. So that's what we will be doing. I hope you have understood the required why width is required, and we already know that how we can calculate width, right? Now what we are going to do is understand it that step by step. Okay, so let me draw a stack for you. Perfect. So this is our stack. Here I'm going to store what? I'm going to store indexes as well as the value. Why index? Because we need to calculate the width as well. So index value. Perfect. So first, 0th index, right? I'm going to push a value 4. I'm going to push until I see that the element is greater, the element height is greater. We are going to see. So 2, we see that 2 is less than the top element of our stack. So we are going to simply push it 1 and 2. Now for 2th index, we see 0. Let me erase this, right? We are going to make answer again. Yeah, perfect. So 2th index, we see that 0 is less than the top element of our stack. We are going to push it. Now comes the important part. Now we get at 3. So we get at 3. So we know that 3 is the next greater right. 3 is the next greater right as it is greater than the top element of my stack. So let me write it here. I need some space so that I can explain you. First, what is required? What all is required? So next greater right is required. Okay. And then current is required. What is current? Current is the element whose, for example, 0. 0 next greater right is 3 and next greater left is 2. Right? And next greater left is required. And what else? Width is required. Perfect. And now the formula 2, let me bring it here, our formula. So now let's do it. Okay. So here, as we discovered, the next greater right is 3. And for what? For the top value of stack. So we are gonna pop this. So we are gonna pop for 0th value. Also, next greater right, we store our indexes. Right? We are gonna store our indexes. I want to tell you that. Okay. But and next data left. So next data left will be the top element of your stack. So the value, I'm writing value here. Okay, but we know that we are storing indexes. So the value is 2. Now to calculate my width, my formula was next greater right minus next greater left minus 1. And here I have to do the work in basis of the indexes. Right? So the indexes is what? The indexes of my 3 is 3, and for 2 it's 1 minus 1. So that gives me 1. Perfect. So by this, if I try to compute, I will get minimum of 3 and 2 minus height minus 0. That will give me, that will, that will give me 2. Perfect. So that means here at 2 index, I can put 2 units of water. 2 units of water will get trapped. Right. So 2 units of water got trapped. Write 2 here. So here, for the first example, I showed you like how it is actually working, but now I will keep it simple. We already know how to calculate width. We are going to calculate now the next data right, next data left. Okay, so stay with me. Now again, we check if 3 is greater than the top element of stack. Yes, 3 is greater. So again, 3 is greater for which element? For 2 value. We are going to pop 2. And the next data left is the top element of our stack, that is 4. Right? By using this, of course, we can calculate the trap water. So minimum of 4 and 3 minus 2. That is what? 3 minus 2, 1. So here at 2, you can store 1 unit of water. And don't forget, this time I want to show you the width important. Why width? Calculating width is important. So for width, what will it be? So next greater right is 3. That is 3. Next greater left is 0 minus 1. That gives me 3 minus 0 minus 1. That gives me 2. So what will be my width? I have to multiply. As we discussed, there is a change in our formula. Of course, we have to multiply with my width as well. Right? I want to indicate it with a red pen. Width. Right? So here we'll multiply it by width. So our answer into width, that is 2. That gives us 2. So here water will get trapped here as well as here. Okay, now again I'm going to check if 3 is greater than the top element of our stack. No, it is not. So we are going to simply push it. 3 and 3. Now we get a 2. It is less than the top element of our stack. So we are going to push it for 2. Now the important part, we are at 5 and we see that 5 is greater than the top element of our stack. So the next data right is 5 for what? For value 2. Right? For value 2. And the next getter left is 3. So by this, we can use the formula 5, 3, next data right, next data left minus my current. That will give me 1. Right? So here for 2, I can store 1 unit of water. Perfect, beautiful. Now, again, I'm going to check if 5 is greater than 3. Yes, it is greater than again 5. And my current is going to be 3. I'm going to pop this. My next data left is going to be what? Next data left is going to be 4. So by this, I can calculate my answer. Let me create some space. So here, let me raise this. I know it's taking some time, but I mean, it's very important, very necessity thing that I want to tell you that confuses people. So where were we at? So next 5, 4, whichever is less, 4 is less, minus 3. That gives us 1. So for 3, 1 height, right? And here we are going to calculate our width. So width will be 4, right? So we are going to multiply by 4 and here like this. Perfect. Now we are going to check if 5 is greater than the top element of our stack. Yes, 5 is greater. So now what we are going to do? 5 is greater than the top element of our stack. So 5 will become our next greater, right? Our current will become 4. We are going to pop this. And now I check. I check what? That my stack size is 0. So here my stack size got 0, right? And why is that? Why my stack size got 0? Because for 4, no next gator left exists. So if that's the case, I'm simply gonna break. So that's it for the explanation. Now let's code it. Okay. So first, let's create a stack int st. So let's create a variable water trap that is initially 0. Perfect. So int n equal to I dot size. Now let's traverse the whole array for int I equal to 0. I is less than n, I plus plus. Now let's extract the value. Int value equal to height I. Now first while is greater than, while stack dot size is greater than 0, and now the important part, and if your value is greater or equal to, that means that it is your next great element. So its value is greater than the top of your stack, st dot top. If that's the case, then your next greater right is going to be your I. Perfect. What will be your current? Your current will be stack dot top, and then you have to pop it, right? st dot pop. Why is that? Also in current you extract a value, right? So height st dot top. Now st top so that you get your next greater left. So int next greater left is equal to st dot top. Now let's calculate our width. We know we are required our width. So we know that to calculate width, there is nothing, just next data right minus next data left. We are talking about indexes here, right? Minus 1. So we calculate our width. Now we can simply calculate. So the formula was water trap plus equal to that. I'm gonna add all the water I get. So of minimum of height. We need value, right? Next greater right value, next greater left value, minimum of next minus current, right? Minus my current height into width. So into width. Let me add a bracket here. Yeah, into width and a semicolon. And then don't forget to push your indexes. We are making stack on indexes, right? So that we calculate our width, and then simply return your answer. That is the water trap. That is water trap. Okay, now let's try to run it. And if there is any error, let's resolve it. Segmentation fault. Let's see. Very interesting error. Let's see. So here we discussed if stack.size is equal to 0, we have to break it, right? So here we forgot to implement it. So if stack.size is equal to 0, right? And then we break if that's the case. So now let's try to run it. Perfect, accepted. Now let's try submitting it. Perfect. So here, that's it for this video. If you liked it, do not forget to like, comment, and share. Thanks for watching.